Hello everyone, welcome to my channel. In this video, we are going to learn about the basic principles of experimental design in research methodology. So there are three principles of the experimental design. They are randomization, replication and local control. So first, we will know about the randomization. So randomization means we are going to randomly assign treatments to the experimental units. This helps to ensure that any differences between the groups are due to the treatments, not to other factors. This principle employs a random method to treatment assignment to experimental groups of participants. So there is a equal chance, there is a equal probability of being selected from the group of participants. It is regarded as one of the most dependable processes, owing to its capacity to provide an equal chance for each experimental group to receive any of the possible treatments. So it is a dependable process. So based on the capacity that it owes, so there is an equal chance of being selected from the particular experimental group. For suppose there are some cards. So there is equal chance of being selected by all the cards. Suppose I am having 12 cards in my hand. So there is so we can randomly pick any of the card. So there is equal chance for every card in my hand to get picked up. And similarly, I am having a bag of balls. So in the bag with the different balls, so there is a equal chance of being selected. So we can pick any of the balls. So all the balls in the bag are having equal probability of being selected. This eliminates any bias or variance, resulting in more authentic experimental study. So it eliminates all the partiality and it allows every variable in the experimental study to get selected. It gives equal chance to all the variables in the experiment. So next one is the replication. Replication means repeating the same experiment a number of times in order to get an accurate measurements. So repeated application of the basic experiment to multiple experimental units. So we are going to repeat the same process, same experiment repeatedly. So we are going to apply the same experiment multiple times on the experimental units. Basic experiment gets applied multiple times throughout the experimental research. So we are going to apply this basic research on the experimental units multiple times. The repeated application helps in measuring variability and to draw conclusions. So this repeated application of the particular experiment on the experimental units allows us to measure the accuracy. So how accurate that experiment is being performed and to draw the conclusions and variability. So to derive the conclusion from the given units. Replication is important for increasing the precision of the results of an experiment and for reducing the effects of random variation. For example, if you only test the new fertilizer on one plant, you cannot be sure that the results are generalizable to other plants. However, if you test the fertilizer on a large number of plants, you can be more confident that the results are accurate and reliable. Another example is testing a new software program on multiple computers. So if you are testing the new software on multiple computers, it will give you the accurate that how the software is working on the computers. So how many computers that particular software is working properly. Replication is an essential part of the scientific process. By replicating experiments, scientists can be more confident that the results are accurate and reliable. Next one is local control. Local control focuses on increasing the experimental precision through the exercise of control over extraneous variable. That means it will control the external variables effect on the experiment, and it increases the quality of the experiment and accuracy of the experiment. The influence of other variables that may not be part of research characteristics but have an effect on the treatment itself gets minimized. So the variables which are not a part of the experiment and which are affecting the particular experiment will get minimized by using this local control experimental design. It has been seen that all extraneous sources of variation are not eliminated by randomization and replication. That is, they are actually unfit to control the extraneous sources of variation. There are a number of ways to control for extraneous variables. So one of the approach is balancing and another one is blocking. So the first one is the balancing. Assignment of treatments to experimental groups in a way that the treatments are allocated in a balanced manner. An experiment is being conducted to compare the effects of two different teaching methods on student achievement. The experimental units are blocked by student ability level. Balancing involves assigning the treatments to the experimental units in such a way that the groups are as similar as possible in terms of all extraneous variables. For example, you could try to ensure that the groups of plants in your experiment have a similar average size and location in the garden. So next one is the blocking. The grouping of similar experimental units together to create homogeneous groups for treatment purposes. That means we are going to divide the experimental unit into multiple number of similar groups. Okay, we are going to divide them into similar blocks. So in order to perform the treatment. For example, you could group the plants in your experiment into blocks based on their size or location in the garden. Once the experimental units have been blocked, you could randomly assign the treatments within each block. In this way, the treatments would be equally distributed across the different blocks, and any differences between the blocks would be balanced out. By following the principles of randomization, replication, and local control, researchers can easily design experiments that are more likely to produce valid and reliable results. So this is about the basic principles of experimental design. Thanks for watching.